Okay, hi everyone. It's already 10 minutes past 3. I think that was about enough time for people to join. The rest can just join us as we keep going. So today, welcome to our GIS webinar by EcoSpace Services. We'll be looking at several things. So let's look at the agenda. We'll discuss the definitions and applications of GIS, some data types and models, including vector and raster data, mapping techniques in GIS, mapping approaches, available courses, and discounts. Also, if at any point I'm not audible, please react or raise it in the chat. I'll see it. So the definitions of GIS. GIS can be defined as a system for capturing, storing, checking, manipulating, analyzing, and displaying data which are spatially referenced to the Earth. So what this simply means is that GIS is used to store your data after capturing it from, let's say, the ground. You go to a field, you collect your data, you store it, you check it for errors, you manipulate it in a way that you can use it for other processes. You analyze it by looking at aspects such as correlation, dependency, and you also display it in a visual format that can be easy to understand for a non-technical audience. It can also be defined as a powerful set of tools for collecting, storing, retrieving, transforming, and displaying spatial data from the world. So consider aspects such as mobile GIS. When you're using mobile GIS, you get a form, you go to the field, you collect your data, you'll store, retrieve it, and then display it later to a map format, let's say from your mobile GIS, and display it in either ArcGIS, QGIS, or any software of your choice. Also, if I'm first, please raise your hand. So the objectives of GIS are generally threefold: for better productivity, better data management, and more effective planning and decision making. For the first one, think of an example such as citing a new business. If you want to cite something, let's say a shopping center next to a residential area versus next to hospitals, you'll find that your business will be more productive if it's set next to residential areas as compared to hospitals. Why? Because your target market will be the people who are residing in those residential areas. Also, for better data management, reduction of data redundancy and ensuring faster data access. Imagine you're in an organization and all of you are working towards one main objective. For example, we can use something like Kenya Forest Service. You have the seeding department, you'll also have the forest conservation department. All of these are within one simple organization, right? But then if all of us keep collecting the same data for the same purpose, it will lead to redundancy and strain on your database. So that's another objective of GIS, for better data management, especially in an organizational setup. And then also for more effective planning and decision making. For example, in the development of a flood evacuation plan, you can also see some other aspects such as when Kenya Red Cross is using to look at, say, aspects such as disasters. If Kenya Red Cross is supposed to be at a specific site, they'll use GIS to find the location of that site and then reach the target destination in a faster way by looking at aspects such as access routes, the transport, the network, the traffic, optimization, etc. So what can GIS do for you? GIS can perform geographic queries, i.e. database searches, geographic queries, finding land suitable for development. For those of us who've interacted with suitability analysis, you know that we usually use different data layers. Like, for example, if we want to do a suitability analysis for a certain crop, you look at factors such as the climate, where we have temperature, we have rainfall, we look at the soils that are present there, the crops that are around there. You look if the area is being affected by certain pests that attack your crops. You can also get data from other farmers in something that's called PPGIS, which we'll talk about later here as well. But it's where people usually use the mobile GIS forms to contribute towards the overall process. So you'll find that a farmer might see there's this problem in their specific locale, right? And then they indicate that problem. So the next farmer knows this farmer faced a problem with this pest. And this is how this farmer used a method to eradicate that issue. GIS can also be used to improve organizational integration, which we've also discussed in the objective section, in terms of management of organization and resources. So we can share your information. That's where it's written interdepartmental information sharing. We link our data sets by geography. You can consider also businesses that have different branches. This branch can collect its data, another branch collects its data, and then, wait, let me see, there's someone who needs to be admitted. Give me 1 minute. Okay, fine. As I was saying, for improvement of organizational integration, you can have different branches. So when these branches collect their data, it all goes to the master office. That will allow us to do information sharing. A shared database allows a collect once, use many approach, in the sense that when you collect your data, it isn't necessarily that it's only one user who will use this specific data. It can be used by person A. After 5 years, person C can use it. After 10 years, person D can use it. Or maybe person A from this department can use it. Another person from person C, another person from another department can also use the same data. Then we have map making. It's more flexible than traditional manual approaches. Think about it this way. When you're doing your GIS mapping, in case you encounter an error in a map, if you had a manual map that's physical, i.e. you've printed it, versus one that's on the computer, it's easier for you to edit and correct any mistakes that have been seen, as compared to the one that is printed, where you'll have to go back, correct it, draw everything else, print it once more, which wastes your time as well as costs. Also, map products can be centered on any location. Think of it in the aspect of something like NDVI, which is the Normalized Difference Vegetation Index. For NDVI, use two bands, that is the near infrared and red. Once you perform a normalized difference, I hope I'm being understood, but yes, you can ask questions at the end. There'll be a section for Q&A. But once you have this NDVI product, you can just change your area of interest and then apply the same product to somewhere else because you're using the same set of formulas. Also, things like land cover maps obtained from satellite data, elevation maps for DM, rainfall maps, flood risk maps. Flood risk maps, you can look at your historical data versus the current condition so that you can tell if an area is prone to flooding. Applications of GIS, we have a number of them. GIS can be used in agriculture, natural resource management, land management, all of this that you're seeing here. Tourism, insurance, marketing. For example, in the natural resource management, you can use GIS to manage your minerals, forests by monitoring their distribution, health, changes over time, tracking biodiversity, which is the existent species in the specific area. In agriculture, you've also seen things like suitability analysis. There's also sensors that are being used for precision farming, such as YARA-N sensor, which looks at the variable nitrogen rate. Then there's also urban planning for design management of cities, such as zoning, planning, crime analysis, mapping. If you look at, let me give a specific example. In case you, okay, let me admit someone. As I was saying, looking at something like crime analysis and mapping, if you want to identify the areas in which a lot of crime is experienced, you can look at factors such as alcohol outlets. For example, if you've noticed that crime is experienced so much where alcohol is being sold because of the rowdiness of someone's behavior, people are drinking, losing their sense of mind, you can put that as a factor in your GIS and say, in this area where there are plenty of alcohol outlets, there's a higher risk of crime happening than in an area where there are no such outlets. Then we also have utility management, things like looking at power grids, pipes, all that for marketing, navigation, advertising. For example, in advertising, you can use GIS to target your market analysis by mapping your consumer demographics, e.g., You can't go somewhere to sell, let's say, dresses in a place where people are only wearing trousers. Maybe you're in a male-dominated area, people are only wearing trousers in that target market, and you want to sell dresses. Of course, you won't get clients there. You can also use GIS to track your competitors, to optimize your locations for siting your businesses. All of this, tourism, governance. Okay. So there are different data types and models. We usually have vector data, raster data, and then now attribute data is usually more of a subset of what's in the vector or raster data. For our vector data, it exists in terms of points, lines, polygons. For example, a road, that's a line, a river. We have lakes, buildings, hospitals. A point can also be classified as a polygon depending on the scale. For example, if you're mapping an area such as Kenya, you'll have your hospitals as points because it will be easier to identify it. But if you're looking at an area, let's say Njiru area, and you only have 2 or 3 hospitals, you'll map them as polygons. So your feature shapes are defined by your XY locations in space. That is basically the longitude, the latitude, your coordinates. And then raster data, features are represented as a matrix of cells, pixels in a continuous space. For this, you can consider data such as land use data, land cover data, soil data, because the soil will be continuous at a specific geographic location. You won't find, let's say we are looking at plot A, you won't find clay soil, loam soil, sand soil, alluvial soil in the same geographical region. Of course, it has to be continuous, then at some point breaks, then another soil type, etc. Because you also look at aspects such as good drainage, rainfall, all that is represented by raster data. Then we also have attribute data, the characteristics of the data, which is descriptive in nature. For example, if you have someone's ID, there we all have ID numbers here, right? So your ID number will link your name, where you are, your phone number, all of that. That is the attribute data that's linked to your vector data now. For example, when you're doing sensors, they'll pick your details, but they'll have one unique identifier that connects all details. Let's move to the next slide. So mapping techniques in GIS, we have different mapping techniques. We look at choropleth mapping, where the areas are colored or shaded based on data values. For example, population density, crime rates. If you can look at this map here for Africa, you can see areas that have high population density. If we had something, let's say crime, and we're looking at an area, a specific area, the intensity of the color would tell you if something is higher in that specific area. We also have dot density mapping, which uses dots to represent a quantity or phenomenon used in aspects such as city population, sales volumes. So for this, consider you have a data set. Let's say Kenya. In which county? In Meru, you sold 50,000 items. In Nairobi, you sold 20,000. Let's say in Kisii, you sold 5,000. So the distribution of dots will show by the volume of what you sold. The more the dots, the more the phenomenon happened, the more quantity you sold. Then we also have heat mapping, it's a rhythmic mapping. If you can look at this map, you can see that there are areas that have brighter colors versus those that have lower color shades. So it shows the intensity of data in a continuous surface using gradients. You can use it for crime hotspots, traffic incidents. It works well for point data that is clustered. Let me add someone. Yes. Or dense. Then we have the contour mapping. If you've seen contour maps, you would understand why this map exists here. So it uses lines, i.e. contours or shaded bands, to represent continuous data used in aspects such as topography, weather patterns, noise levels. It requires interpolation of point data to create smooth surfaces. We also have cartogram mapping, 3D mapping. So cartogram mapping, it distorts the shape or size of areas based on the data value. You can look, if you look at this map right here, this is the entire world. But look at the shape and size of Africa. Then look at Canada right here. You can see that Canada, the size and the shape is exaggerated, but it still communicates the specific aspect that is being discussed in this map. So that's why a cartogram is good for storytelling purposes. Like you can explain what you're trying to indicate. I'm seeing two people trying to join. I don't understand what's going on there, but it's fine. Okay, it's best used for storytelling and not precise location data. For example, if someone didn't know Canada is located somewhere here, they'll wonder what's going on at this specific region, right? But someone who knows that this is a cartogram can tell that this is showing that there's a higher value or something around this area. For example, election results, economic indicators. If we look at the map of, let's say, Kenya, and we want to see which party had more votes, it will exaggerate the size of the specific counties based on the political party that we're looking at. Then we have 3D mapping. It uses elevation or extrusion to visualize terrain or attributes in 3D, use case, urban planning. If you can remember, we usually have some 3D models that will show you the buildings, infrastructure, all of that. Now that is the 3D mapping. You can't see what's being presented? Please react. Can you see what's being presented? I hope so.
So, Anita,
Mm-hmm.
hello.
Hi, I can hear you.
There's some people who are saying the screen is not shared to all. So I don't know. Leonard, can you see what's been presented?
You can't see what's being presented?
Yeah,
Wow.
even some people in the office say they can't see.
And they have been presenting. I thought everyone was seeing. Let me use another method. Let me stop sharing. Stop presenting. Let me share with a different method. So you haven't seen the presentation from the beginning?
I personally have, but some people there's someone saying they haven't seen.
But some others have.
Yeah, some can. Purity can. Leonard, can you see now?
No, I've stopped sharing. Right now there's nothing being shared.
Okay.
But some could see and some could not. Haven't been seeing. That's interesting. Okay. Let me share in a different way. I saw some people trying to join. Wow. Can't display presentation too. Okay. Let me use a different method. Give me 1 minute. Let's use. Okay. Is this visible for everyone? Leonard, is it visible for you? But if I'm sharing with this method, I won't be able to see what's going on the team's end. So reactions, chats, I won't be able to read them. Can everyone see? Let me see. See. Okay, it's fine. So this was the presentation I was displaying. This was the first slide where I was talking about the GIS webinar. We looked at the agenda, the definitions, applications. I'm just going through the slides once more, faster for anyone who hadn't seen it. Let me minimize this. Okay. And then what can GIS do for you? I discussed performing geographic queries, improving organizational integration, map making. We discussed some applications of GIS, agriculture, NRM, urban planning, crime analysis, utility management, tourism. Then we were looking at data types and models. So I mentioned vector data, raster data, attribute data. I'm doing this for those who couldn't see the presentation, just in case you need a visual memory. Then we had mapping techniques in GIS, where I discussed choropleth mapping, dot density mapping, heat mapping, contour mapping. We were at cartogram mapping and 3D mapping. And the next slide was now network mapping and time series mapping. I hope everyone is okay. I think QT will help me with anyone having any issue. Yes.
Yeah, sure.
Okay, then we have network mapping, which focuses on connections between points like roads, pipelines, electrical grids. If you can see, there is a small map that has been attached here. This is just a network. So use case for transportation, utilities, route optimization, but it requires good attribute data for network analysis. Okay, let's admit. Then we also have time series mapping. It shows how a variable changes over time on the map, often using animation or sliders. Now, consider an aspect where you're looking at, let's say, urban growth for the last 30 years or so. You take the urban population in 2000, then you take for 1990, you take 2010, you take 2020, and then you want to look at 2030. You can have all these maps as an animation, or you can use PowerPoint sliders, i.e., I make one map on, let's say, this slide, on the next slide, on the next slide. So in the end, I'll be looking at all these maps for the different years, which is now how the variable changes over time. Or you can simply use an animation, which you just have the whole, the boundary of the map, and then the variable that's changing. It depends on how you want to visualize your data and your proficiency in visualization. So the use case is for tracking disease spread, urban growth, deforestation, i.e., I've given the example of urban growth. You can also look at how a disease is spreading, how deforestation is happening, how people are encroaching a wetland. It's useful when spatial changes are linked to time. So we're also going to look at the mapping approaches, static versus interactive mapping. In summary, you can just say a static map is one that you can visually hold and see. Like, which example can I give? Have you ever seen these printed maps that are printed on a paper, or a map that has been shared to you as a PDF? That map, you can see it, and then that has been printed, you can also hold it. Look at an interactive map. You look at aspects such as Google Maps. Right now, everyone can access Google Maps on their phone, or at least I hope so. If you're looking for a specific location where you haven't reached, you can key in your current location and then your destination. Google Maps will tell you the type of buses you can take. If you're using a personal car, now that's an interactive map. A static map does not allow you to do the interaction such as zooming, panning, all that. So this is technically what this slide and the next slide will explain, but we'll still go through it. So static mapping employs the use of static maps. Static maps are fixed, non-interactive images that display geographic data, often printed or exported as images such as JPEG, BMP, PDF, and designed for quick visual communication. Some of the key characteristics are no user interaction. You can't zoom a physical map, you can't pan it, you can't remove certain layers because that is what is existent at that time. It's designed for a specific scale and layout. As you've seen, most maps usually have their scales. and also their layouts. If it's portrait, if it's landscape, once it's printed, you can't change it to be portrait if it's already in the paper unless you go back to your GIS software. It's used in reports, presentations, posters, printed media, and often designed with high cartographic quality. Here you'll find your map elements, you'll find your title, your north arrow, your legend, your attribution, your scale, insets, everything that's supposed to be in a map. That's why it's designed with high cartographic quality. Then we also have interactive mapping. It employs the use of interactive maps, which allow the user to engage with the map content through zooming, panning. There I was explaining about Google Maps. You can be at a certain location, wanting to go to a different destination. You zoom the areas that are around your destination so that you can look at the landmarks, the access routes, the roads. There's panning for toggling for the different locations where you want to check, filtering if you want to check a specific layer. For example, when you're using something like OpenStreetMap, you want to look at only transport networks, you want to look at, let's say, buildings on Google Earth, clicking on features, toggling layers, which I've already explained. Then we have some key characteristics of interactive mapping. It's built using web-based tools or GIS software with web-based capabilities. Then it has real-time or dynamic data integration and includes tools such as search, measure, pop-ups. Then you can also just use Google Maps to input a search area, and then it takes you to either that hotel, that forest, that park. That's technically what an interactive map is all about. Some advantages, limitations, and then use case of these two different approaches of mapping. A static map is easy to share and print. You don't need special software or internet to view. The same way someone can share a PDF of a map to you. You can open it on your phone. You can open it on a laptop. Okay. And then it's also clear and uncluttered, which is good for emphasis. Some limitations of static mapping: you can't explore additional data layers. The way I just mentioned, once you have that printed map, you can't say now you want to look at roads if roads had not existed in that map. You only have hospitals or market centers or police stations. It lacks flexibility. It's limited to one perspective. For interactive maps, the fact that you can zoom allows you to see from different perspectives. You can look at it in a large scale or small scale, i.e., zooming to your specific area versus zooming to look at the whole area in general. It's not ideal for complex data sets. Consider something such as clutter in your specific map. Let's say I have a map, I want to look at roads, I want to look at rivers, I want to look at lakes, I want villages present, I want schools present, I want hospitals present. Okay. Basically, it's not ideal for complex data sets because it will lead to clutter and a lot going on in the map, which will take away the aspect of what the map is trying to communicate. If you see a map that has too much detail, you won't really want to go further and read it because it's already bringing that visual clutter. Some use cases of static maps: they're used in reports, textbooks, posters, newspapers, printed maps. And then the advantages, limitations, and use cases of interactive mapping. Advantages: it's engaging and user-driven, can handle large multi-layer data sets. The same I was explaining that you can decide to toggle on and off a specific layer. It's great for public participation and decision making. Look at things such as OpenStreetMap. They allow users to contribute to the whole mapping process, so that enhances the public participation process. We also have limitations of interactive mapping: requires internet access, especially if you want the most accurate data at that point, can be complex to design and maintain, and may require training for new users. Use case examples: we have story maps, web apps, dashboards, public tools, weather maps, real-time traffic, and PPGIS, which I had mentioned is the public participation GIS. For something like a story map, if in your free time you can just check, but this is something that might require training for someone who hasn't interacted with it before. Same to web apps, dashboards. especially if you're looking at software such as ArcGIS Online. You need to have some training, which we are going to list some of the training courses available with us. So all of these are the courses that we offer as EcoSpace services. We have an introduction to GIS, the same way that we've done in this webinar, but we've literally skimmed through a lot of things. When you do the courses with us for the GIS, remote sensing, it will be more in-depth. There's GIS, we have remote sensing, Google Earth Engine. For those of us who prefer programming, we have GE, we have Python, we also have R. Then there's also things like the drone data processing, remote pilot license for multi-rotor and fixed wing. We have web mapping using GeoServer. All of these courses are available to us. So I'll give 2 minutes, I think 2 or 1 minute, for you to just look. If you're screenshotting, you can screenshot, but all of these are available. And then we also have discounted courses for this period. For the first 30 registrants for these listed courses for drone data processing and analysis, introduction to and surveying using GNSS receivers, GNSS data processing and manipulation, and fundamentals of AutoCAD Civil 3D for surveyors. Yes, we can enter the Q&A session as we look at the next webinar that will be announced. Yes. If you have any questions, you can ask. I think QT will handle the questions unless I have to stop sharing the screen right now so that I can go to my Teams application.
Yeah, sure. So, guys, please feel free to keep these questions coming in our chat box, and we can address them. If you need anything clarified, just raise your hand or chat us in the chat box.
We don't have questions? That's amazing. So you've all understood. I'll pick someone at random to ask a question. Josh, do you have a question? Or a comment?
I'm good. I'm good.
Okay. Let me see who else is in the list. Grace, do you have a question?
No, I don't have a question. Thank you for the
Did you enjoy the
presentation.
presentation?
Yes, I did. Thank you.
Okay, thanks for joining. I think if we don't have questions, I will share the last slides for the courses once more in case we are interested in that. For the courses and the upcoming webinar, let me share it and then we can exit after we get direction from QT. Yeah, I'll pass it over to QT during that time. Beauty. I will share the last slides. I'm just going to pass through them slowly so that they can view. And then after a minute or two, you can take over the exit. Thank you.
All right, that's okay.
Okay, thank you, Cutie. I can hand over to you.
All right, so thank you everyone for joining our webinar. And we appreciate as the EcoSpace team, we do really appreciate for joining us for this webinar. And as the digital person in EcoSpace, I'd actually would love to involve you more. Check out our pages and also follow us, get into those socials, engage. If you have any upcoming queries, we are always open to that. So I'm just going to share our link tree so that you can be able to access all our socials. Just look at them, engage, and for any updates in the future, we're going to share with you guys. And please feel free to join us in our next webinar. We'll be talking about the surveying and AutoCAD webinar, and our geospatial application engineer, Mr. Fred Awiti, will be the one leading the webinar. So please feel free. And we also have the 30% discount on the 4 courses highlighted there in the checklist. So feel free. And thank you so much for joining us. Have a nice week. Have a nice Easter holiday. And enjoy.